Hello everyone, welcome to my channel. So for this tutorial, I'm gonna show you how to build your first PCB board with KiCAD step by step. And here's the result of the PCB board you're gonna make, but this is only an example from the breadboard. So let's have a look. So for this thing, you can use the potentiometer here to adjust the readout from the Seeeduino XIAO analog readout. And after pressing that button there, you can use it to set the expected angle of the stepper motor there. And there's an OLED screen there showing up all the readouts and the button status, which is pretty simple. Yeah. So without further ado, let's get started. So now I'm gonna switch to this main display here. And this is my finished PCB board schematic. It looks pretty messy, I would say, but it is definitely readable. And here's my routed PCB board. So let's start from scratch. So the first thing you want to do is to create a new project here. So I already have my project here named Motor PCB, so you definitely can do something different. Let me say maybe Motor PCB new, right? Okay. So this is the thing I don't like about KiCAD is that it always closes the previous project after creating the new one, which means I've lost my reference here. So don't worry, I've got my screenshot there, so I do have a reference on the other side of the screen. So still have it. Okay, so let's get started with drawing your schematic. So after double click, you've entered this schematic view of KiCAD. I would recommend the first thing you're gonna do is to have the page settings bring up. So here you can enter the issue date of your board schematic, and perhaps you can say like some revisions. So for me, it's the second version of my PCB board, so I'll say V2.0. But for you, I guess it should be version 1.0. The title, I would say stepper motor demo and company. Like this is the field mainly for who created this PCB board, so I will just leave my name here and press OK. Now there it is. Okay, now the second step here is to, of course, add symbols. So as Kevin mentioned from the previous lab, you can have that window bring up here, like place, add symbol, and you can also click this button on the toolbar on your right side. You can also press A, which means add, like that's the shortcut for add anything, add symbol. So, our board's main component is the Seeeduino XIAO board. So let's add that first. So as you can see here, I don't have my imported library here, so I might need to spend some time finding it out because these items are sorted alphabetically. So as you see here, there's a demo folder, and there it is my Seeeduino XIAO symbol. Okay, so assume that you haven't done it yet, like you haven't imported any symbol from anywhere. I will just go through that with you again, which means I'll delete these symbols I've imported for this project first, and I'll add them back there all over again, just for your reference. Okay, so here you would like to press this add button, and here I would say XIAO demo. Alright, because like this is the Seeeduino XIAO symbol we want to import. So go to our project, PCB resources, there should be a 514 KiCAD underlying scene file here. Like that's the file for the shell board symbol. Click open, then click OK, and now you press A, and as you can see, so after the first time you've imported this library or symbol, it will always be showing up on the very bottom of this window. So just click this one, there's no default footprint for it, OK, and there it is. Okay, so that's the shell board I'm gonna use. So as Kevin has mentioned already, this thing is not the physical representation of your board. It doesn't match exactly as your board physically like. What it means is that, let me bring it up here. I'll use my camera. Okay. So here is the shell board. As you can see, there should be 7 pins on either side of it, but even though their count is correct, they still don't match with the same size, which means like this is an abstract view of your layouts, not a physical view, right? But there are some kind of mappings here happening, like those 7 pins are being mapped to the, let me see, to the left 7 pins here. So like they are mapping correspondingly right now. Okay, so that's what they are doing right now. All right, let's move on. All right. So to have my project working, the first thing I'm gonna need is definitely a power source. So I'm not starting with that first. So to add a power, you can press this button, this tool on your right side, and here is a set of power options you can choose. I would like to choose VCC as your power's positive end, and GND for the ground, which means the negative end. So I would add the VCC here, and GND here. Okay, I'm scroll it up a little bit. So for the schematic, the most important thing is to draw the lines here to demonstrate like which nodes or pins are connected. So it's pretty simple. See, there are small circles on the pins of this figure, right? So if you hover your cursor on that pin, it will automatically be connected to that pin if there's a circle there. And after clicking again with another circle, see, those circles disappeared, which means like they are connected. There's no more pins to be connected. So this is pretty neat, which means like you don't need to look very carefully to see like whether they are connected or not. And yeah, so here's the pretty simple 5-volt battery input for the Seeeduino XIAO board. Okay, so this battery option works for most of the boards. ESP32, Seeeduino XIAO, RP2040, I think they all work almost the same. But in case you want to use rechargeable LiPo batteries instead of those AAA batteries, there's another option to use them for the Seeeduino XIAO board. I'll leave them at the end of this video, and I'm not gonna go too deep into that right now. So let's just assume that we are using this way of connecting the Seeeduino XIAO board with the power source. The next thing we want to do is to have an LED there to show up whether the board is being correctly powered. So to do that, what we need to do is to have a circuit in parallel with the MCU, which means that's your board here. If the power is supplied, that LED will be light up, and the MCU will be also working. And meanwhile, we also want a switch to be here so we can control the power of the MCU supply. So I'll switch back to my camera again. So here is the switch we're gonna use. See it clearly? No, it's hard to focus with my camera here. So this is just a pretty simple 3-pin switch. If you are sliding it to the right side, the middle pin and the right pin are connected, and if you are sliding it to the left one and the middle one are connected. So pretty simple, right? Okay, so we're going to use that as our switch. Switch back to my display here. So to accomplish that, we need to add a symbol for that. So we go here. So we're going to find a switch for our circuit. Let's go try switch. There should be a bunch of switches here, like all of them should be working fine, but for our selected one, it should be this SBDT switch. This is because we've got a single blade, a double-ended, so it's SPDT, single, then double, right? Okay, let's select it, bring it up here, yeah, there we go. So another thing we're gonna need is the LED. So let's add them correspondingly. LED, see, it is here. So pretty neat. And since we have an LED here, and it is connected in parallel with the MCU, which means that this sub-circuit of it is actually directly powered by this VCC voltage. I mean, like any LED cannot handle that without a protecting resistor. So that is super important. Every time you want to use an LED, there definitely need to be a protecting resistor to be connected in serial to reduce the current flowing through the LED. So let's click again and search R, representing for resistor. Not this one. Press this one, R. Okay. So we've got it. So the next thing we're gonna do is to have a sub-circuit flowing from VCC to this switch and goes from here to the resistor, then to the LED, and then ground. Right. Okay. So now I'm gonna introduce several short keys or shortcuts for KiCAD for manipulating these elements in your schematic. The first one is pretty simple, which is move. So after selecting an element here, and be sure like you've selected the whole element here instead of just the font here. Like otherwise you are only selecting or manipulating this font or these words instead of the overall component. If you press N, you can then move your mouse without any other things being pressed, and after left click, you can set it there and it is fixed. And we can do the same thing for R1 and LED. And some people might have observed that I've rotated this LED after importing it. So the shortcut key is R. So if you press R one time, it will be rotated 90 degrees. Okay, I think we want it in this way. And I might want the VCC to be higher. So then I can draw a line from here to here then connecting them all together, and see, I've misclicked it, and there's a square here, which means like it is not perfectly connected to the circle pin there. Because if they are correct, the circle pin there should be disappeared. So Control Z, I'm gonna revert and then fix it. Okay. And if you want to copy any element on this schematic, you can just select one, press Control C and then Control V, and there it is. Oops, it's a little bit off. Okay, and now this power subcircuit is finished. All right. So if you are familiar with Blender or any other CAD softwares, you will find this manipulating shortkey things pretty simple because it works almost the same in different softwares. All right. Okay. So now the second thing I want to do is to connect the stepper motor here in the schematic. So for that, we need a symbol for the stepper motor here. So let's go have a look. We press this plus button to add a new symbol. Let's say stepper demo. Yeah, let's see. Okay. So I might be wrong. So there's only a stepper motor footprint file provided for us, which means the stepper motor symbol might already be there in KiCAD. Let's go have a look. So press A, search motor, and yeah, here are the motors. What we want is a stepper motor, so it's not AC or DC motor. It's definitely not motor servo, but this stepper motor bipolar thing. Okay, so I can have a closer look at the stepper motor here. See, so this white thing here is the stepper motor. Its model name is X27168. So it has 4 pins on the bottom, and on either side, those 2 pins are connected to a coil, and there's a upper bar there to control whatever thing you want to control, right? So the 2 coils here are being used for generating 2 magnetic fields in total, actually, and it is using that to control which angle that motor should be turning to. Okay, so those 4 pins can be directly connected to your MCU analog output pins, so that you can use it to control the stepper motor's movements. All right. Okay, let's switch back. Okay, I'm not gonna go too deep into how these stepper motors work because this is not pretty important for our project right now. And if you're curious, these stepper motors are being powered or controlled with PWM signals. And if you Google that, you will see something like this, like pulse width modulation, which is a kind of a discrete, cyclic, or periodic signal here. And these kind of signals can be generated with either software or hardware. And these stepper motors models, which is X27168, and if you Google them, my default search engine is being not Google. Okay, so if you search it, you'll see something like this: automotive gauge stepper motor, and this is the driver provided by Adafruit, which is this TB6612 board. And the advantage of this board is that its powering circuit and controlling circuit can be totally destroyed or irrelevant to your MCUs, which means you can have different power voltage provided for your for your motor instead of that like 3.7 or 3.3 volt power supply from your motor from your MCU. And its controlling logic is totally asynchronized to your MCU, which means like any operations you are doing on your MCU, like serial printing or display printing, will not block your stepper motor's control. This is pretty neat if you have several, well, like something complicated calculations happening on your MCU. So they have some advantages, but for now, my point is like it is definitely possible to power and control this stepper motor directly from your analog output pins on your MCU without using any drivers. And if you do have those specific usages, say like you wanna have some complicated computations on your MCU and you want the stepper motor's control to be non-blocking, we can definitely use a driver. All right, that's it. And let's go back to KiCAD here. So we're gonna select this one, bipolar stepper motor, because our stepper motor has two coils with 4 pins in total, and add it here. And then we can just use this wire to connect them to the analog pins on your MCU. Each time those pins are connected, these circles will disappear. And don't worry, like if you have these wires came across with each other, as long as there's not a circle like this, a solid circle, it means like they are not being connected like a crossroad, right? They are being crossed like a bridge, and this wire and this horizontal wire, they are not connected at all. Okay, so as you can see, like this representation here is kind of weird and complicated, and like perhaps not so easy to read. I'll have something covered at the end of this video to show you how to properly representing this in the schematic using labels and separated unit circuits. Okay, so this stepper motor thing has been done, and now what we want is the OLED screen. So as we all know, the OLED screen is being controlled by the bus wire, which is using the SDA and SCL pins on your MCU. So by default, there's no OLED screen symbol or footprint on KiCAD, but fortunately, what we have is Google. So let's try Google it. SSD1306, which is your OLED screen model name. OLED symbol KiCAD. Let's try this and see here. KiCAD footprints and templates for SSD1306. Well, this is nice. This is exactly what you want for your project. Because as you can see here, this is the SSD1306 for your OLED screen, and it should be looking exactly the same for that one, right? Okay. All right. So the next step is, of course, to download this or clone this repo to your laptop. But don't worry, I already get it down, and I've also have it uploaded on GitHub, so don't need to worry about that. And now we go back to the KiCAD library and try importing that from here. Manage some more libraries. But plus button and say SSD1306 demo Yeah, it is being uploaded by me under this folder, PCB resources, SSD1306. And so this time you're gonna import this .lib file, not an underline SYM file, but they works almost the same. Okay, press OK. Take some time. SSD 1306, and there it is. Okay, I'm gonna put it here. I was pressing the ESC button on my keyboard to exit the add symbol function of KiCAD because I want to move this label here, well, maybe to here, to a place that is not like blocking my OLED screen connection here. And then I can connect SDA to SDA and SCL to SCL. Okay, so here's the problem. Like these solid circles here means that this wire or this line is connected to both GND and VCC pins here. So this is definitely not ideal. So I need to revert this and try different wiring. Okay, so there we go. Like there's no solid circle here, which means like there's a bridge, not a crossroad here, so which is perfect. All right, and the next thing we're gonna do is to have this ground and the VCC connected. So let's have this GND and VCC copied. This will look ugly, of course, but don't worry, I will show you how to build them in a better way later. So for now, all the things I'm doing is to make this thing work. Okay, not perfect, but it's working. Okay, so that's the end for the left side of it. And all the pins we can use has already been used. This TX pin here, if you look carefully for the Seeeduino XIAO datasheet or documentation, XIAO ESP32S3. Okay. If you check this out quickly and carefully, no, I want the documentation or wiki here. Okay. So if you check the pin out here carefully, you can see like there's no analog function for these two pins, D6 and D7. They can read digital inputs, of course, but not analog inputs, which means like they can know binary things like 0 or 1, but not continuous values ranging from 0 to 4096, which is mapping to like 0 and 3.3 volts. All right? Okay. So I've now finished the stepper motor part, OLED part, and the powering circuit. What is not being implemented is this section. So what I want is a potentiometer to adjust the analog input reading, and then I can use it to switch the angle of the stepper motor. And another thing is the button, which is being used for setting that analog reading as the next stepper motor's target angle. Okay, so I need to finish those two parts next. So let's start from something, well, easier. Okay, so maybe let's start with the potentiometer. So we can use add search potentiometer, and there we go. R potentiometer because like potentiometers are resistors. So it starts with R. And we can use R shortkey to rotate it. So to be aware, like if we directly connect VCC, then to the potentiometer, then to ground, there's no analog we can control. That's because like the voltage between those two pins of the potentiometer will always be the voltage between VCC and GND. So what we need to create here is a voltage divider. So we need another resistor to be here to split that voltage between VCC and GND. So add R, another resistor. And perhaps I would like to put them in a... No, I still feel like this way is better. Okay. So if they are being put in serial, they can formulate a voltage divider circuit, and then if we can adjust the resistance of the potentiometer here, its voltage across those two pins can be adjusted because like they will be summed up as the VCC voltage readout, but the splitting strategy here can be adjusted by us. Okay. So let's finish the connection here. Let me check. I was using which pin? This looks ugly, but okay. All right. So we need to power this voltage divider circuit first. So we have two options actually. The first option is to use this 5 volt or VCC input as the input voltage. The reason is that it is pretty, how to say, direct, right? Like there's no complicated things going on. But the problem is, as your power battery being used, the voltage of your power supply will be continuously decreasing later and later. So its readout or its output, its total voltage output readout will be inconsistent. So that will create a circumstance that your analog reading from that potentiometer pin is being controlled by the power supply's output voltage and the resistance of the potentiometer. So if we want to get rid of that influence from the power supply, we should be using this 3V3 pin here from the MCU. Because if we check it out here carefully here, let's see. So you need to go through this documentation by yourself as well. So let's see. This is the regulated output from the onboard regulator. You can draw at most 0.7 amp, so which is like large enough. But one thing to be mentioned, like to be noticed here, is that this voltage output is regulated, which means it is pretty stable. Okay, so that's the reason we're gonna use that as the power for this voltage divider. And then we are gonna use this to create a voltage divider circuit. Okay, there we go. And even though this might look pretty well to you, there's still another thing we haven't done yet, which is to read the analog or the voltage in this voltage divider circuit. So that should be something be pointing from, let me check which one I was using. I was using D9, so okay. So that would be the thing pointing from D9 to somewhere. Will this be here? Of course not, right? Because if it's here, it should be always 3.3 volt. And if here, it should be always 0 volt. So we need to connect this thing, this wire, to somewhere in between. See, there's a solid circle going on there, which means like these three wires are totally connected. Like they represent the same spot on your PCB. All right. So that's the end of the voltage divider circuit. Now I just found out like there's an error for my schematic right now. Like if you wanna solve this problem by yourself, like you can pause this video for now and try to think like which thing is being connected improperly for my schematic, like for my circuit right here. Okay, I will give you 3 seconds. Okay, 3, 2, 1. Okay, so obviously, like my switch here is being improperly or incorrectly connected because, as you can see, this VCC can be directly directly connected to the 5-volt pin here. This switch here is doing nothing right now. Okay, it is only controlling whether this LED is being lighted up or not. So we need to fix this. So what we are gonna do is to move this a little bit higher, and I want to get rid all of these wires. So I'm not sure like what's the keyboard of deleting a wire on Windows, but like on my MacBook it is backspace but not delete. So you might want to try both. Okay, and rotate for R, and R for rotate, and N for move. And oh, I don't like this. Oh, okay. Just get rid of it and do this all again. Okay, there we go. It looks better right now. All right. Now let's just get it done for the final part, which is the button to set that potentiometer's input as the angle or the target angle of that step motor. So we need that part of circuit being built. So first, we need to put all the components here at once. That might give us a better understanding of this thing. So what I'm using is a button. So you can search button here. But as you can see, like there's no button showing up here, which means it is actually not being called a button, but a switch. Because they are mostly the same, button or switch. A switch is a thing that if you slide it to a side, you don't need to hold it, and it is there like forever if you're not touching it. But like a button is something like if you push it, it will be connected, but like if you are not, then it's disconnected. So like button and switch, they can be the same thing. So what we need here is actually not a button, but a SPST switch. A single blade, I don't know what it stands for, like what it's short for. Just a single blade, but a single direction or single target to go to. Remember, like that previous switch where we were using was SPDT, which means single blade double target, maybe, right? But now it's single target. So, oh, single throw, yeah, single pulse, single throw. Okay, there it is. All right. Not good at these electronics like terms and names because I'm not from this background, but like I mean, if you get it, then it's fine, right? Okay, so this is our button. If we are pressing it, then this thing is being pushed to pin 2, and this circuit is closed or connected. And if we are not pushing it, it is open or disconnected. All right. And to better debugging our circuit, I would like there to be another LED here to show like whether the button is being pressed or not. And since we are using a LED there, we need a protecting resistor there to control the voltage, control the current of that part of the circuit. And okay, here's the thing. So there are two different kinds of ways to use a button or a switch. The first kind of way is being called active high and the other active low. I think Kevin must have talked about that a little bit during his lecture. So what I wanna further do is, let's check it out. So high and active low button. So I found this tutorial pretty useful and pretty, how to say, pretty straightforward. Oh, it's not here. Let me check if it's here. Button. Okay, there we go. So active high versus active low button. So here it is. So active high is more like straightforward, which means like if this switch is closed or connected, the power provided from VCC can flow into your MCU, and that's it. Right? And if not, it is going to nowhere. This is just an open circuit. Okay, the light is up. And if for this active low circuit, when the button is being released, not being pushed, the VCC can go to your MCU analog input, which means like that digital or analog readout would be high. But if you press it or activate your button there, your MCU will be shorted because like that that current can go straight to the ground instead of going to your MCU. So then your MCU's voltage readout will be the ground, which means 0 and low. So it's active low. Active means like you're pressing it or activating it. All right. This is pretty straightforward, right? Okay. So let's create a active low button for our readout here. I'm gonna first select them all and have a VCC here. So this might look ugly, and if you are from an electronics or ECE background, don't laugh at me. Like this is definitely not something really, how to say, ideal or like professional. I mean, like I'm not professional on this field, so all right. Let me see. Okay, okay, and need a G and D here, and I just wanted them to be on the same line or same column. Okay, and I can actually, should I do this or not? I think, yeah, I think this is fine, but not really ideal, because this VCC here can be like bigger, larger, higher than your absolute maximum reading of your analog input or other input or output. But this 3v3 output can not go higher, and its maximum value is 3.3 volts. So I'd rather use that one as the power here. So what I'm gonna do is okay. All right. So now, could anybody please tell me like what's wrong with my circuit of the button right now? Okay. I'll still give you 3 seconds of finding that point out. Okay. And you can definitely pause this video and try to think about it with yourself. Okay. 3, 2, 1. Okay. So what's wrong with this circuit is that if this button is being pressed and this circuit goes to 2 and this circuit is closed, the analog readout here won't be 0. It will still be 3.3 volts, right? It's like they are being connected all the time. Is that true? Okay. So what we need is definitely not something connected directly from 3v3 to here, right? This is incorrect. Okay. I need to move this I need to move this part of the LED here. And this one here, maybe like this. And I want the 3v3 to be connecting to here. And then like this. And bruh. Does that look good? I'm not sure. Let's check it out. Okay, so 3v3 goes to here, and oh, I haven't used that thing, right? Like what analog should I want to use? Should I use? So if it's open right now, the readout here would be 3v3, right? But like if it's being closed, this one should be 0. Okay, so there we go. We want to read a thing here. All right. Okay, so this is our button. Okay, so now I would say like it looks like our circuit is being fully built, at least for the schematic here right now. Let's go have a look. Let's use this electronic rule checker. We can run this ERC. Oops, too many errors. Well, okay. Let's see. First, okay, TX not connected. Okay, 1411 not connected. So for this thing, what we are gonna do is to do some like professional thing of representing these pins are not being used. Okay, so here you can see like there's a small cross there. It says like add a no connection flag to your pins. So let's just cross it, cross it, cross it, right? Anywhere else? Anywhere else? Nope. What's the error here? Let me check. RV1. Input power pin not driven by any output power pins. Oh, okay. So apparently I'm incorrectly plugging this VCC to GND and GND to VCC. Boom, that's a large short. Wow. So I'm pretty fortunate that I'm only doing this on KiCAD schematic, not real life. Otherwise, like, the battery will be bombed. Okay, okay. Let's do this ERC one more time. Still 3? Why? Why so? Power hidden pin. Pin not connected. Okay, I'll do that later. And input power pin not driven by any output power pins. This one is weird. Okay. Okay. Let me check this out. Why? Okay. So, as we can see, like, the problem here seems to be like input power pin not driven by any output power pins, right? So this is a typical error on KiCAD. What I would want to do is, of course, Google it. So input power pin not driven, KiCAD. Okay, so here it says ERC error, which is the error we are getting. So let's see. I can make the ones for the power connection go away by connecting a PWR flag to it. Okay, that might be the solution for it. Let's check. Okay, like this, like you basically solved it. You can use that flag on your ground net as well, not PWR ground. Okay, might be useful. Let's check Reddit or KiCAD. Okay, it says like for KiCAD, GND, and other power symbols like VCC are sort of global labels, so they don't mean anything about power. And so like if you are using ERC function there, it cannot figure out like where are you getting the power from. So like we need to add power flags to the ground, and you again should solve the problem. Okay, sounds fair. Let's try it out. So let's see if we can find that PWR flag. Okay, it is here. Yes, I pressed A for add a symbol. Like I'm sure like some people can already like guess it correctly. So where should I plug it to? Maybe just here. It looks ugly. How about this? Maybe just here and here. Let's do ERC one more time. Run ERC. Done. Oh, there is pins of type bidirectional and power output are connected. This is strange. Shall I get rid of it? Oh, still an error. So it definitely wants this on the ground, but it just doesn't allow me to connect it to that GND pin. And I don't know why. Okay, let's do this again. Done. All right. Okay, there's only one warning there. Like, like if you are a programmer, a developer, like warnings means warnings mean nothing. Like, if as long as there's an error, you can go get along with it, unless there are a bunch of warnings, like they are pretty like disturbing, like otherwise don't need to mess around with that. Okay, so as for now, we've successfully built a not so easy but not so complicated circuit for our small project. So I'm gonna keep pressing Control and S to make sure that my project is being saved continuously from time to time because like I really don't want my work to be lost, right? So I assume same as you. So now we can go to this PCB board editor and here we go. Press this button to import that schematic to the PCB here. Okay, something goes wrong here because obviously we haven't picked footprints for those things. All right, let's go back, right? So we've missed a essential step of it, which is to assign the footprints. Well, nothing was assigned. Okay, good. Let's get it done. So to simulate what you are facing, sorry, excuse me, I'm gonna first delete these things and show you step by step about how to import a footprint from other libraries. So here, you need to go back to this view, this window, instead of this schematic view of your PCB of your KiCAD. And click Preferences, then Manage Footprint Libraries, because you cannot find that toolbar there on your schematic view or editor. And just go here, click Demo Motor, because we need the motor's footprint, right? It's not there with KiCAD. So go to my project directory, PCB resources, x27. Here we go. And do remember, I've downloaded the SSD 1306 OLED screen footprint. So I'm gonna do that as well. Go to here, pretty, and demo XIAO. I'm gonna get that. Pretty. Okay. Okay. So I've imported 3 footprints in total to my KiCAD project right now, and it should be globally like picked or like selected. Let's see. Okay, so let's do this step by step. They are appearing on the very bottom of this assign footprints window because like this is the first time we are importing it. And go to here, demo, and it is showing nothing here. So this is weird. Why? Oh, okay. Can anybody tell me? Yeah, because we are filtering out something because there's something appearing. Search bar. Get rid of it. There it is. So if we want to check whether how this footprint looks like, you can right-click it and left-click it. This like view selected footprint. So it will bring up this footprint editor for you. So you can check this footprint here. You can measure it, of course, with the ruler on the toolbar. And you can also edit it if you find anything like incorrectly designed. Okay. All right. So let's select this SSD 1306 and double click here. All right, being assigned. So for the LED, I want the 0805 SMD, means the surface mount soldering, and hand soldering LED here as the footprint. So LED SMD 0805 hand solder. So that's the LED that we are using during our lab 2. Remember, like you've soldered those components on your PCB board. Like 0805 is the largest one on that board, The smaller one in the middle is 0603, and the smallest one there on the right part of it is 0402. And I bet no one, like no one, can solder that 0402 by hand without using any like soldering masks or heat guns, something like that, because it's not meant for hand soldering at all. And for 0603, it could be challenging, but might be doable. But for 0805, like it's definitely doable with your hand solder skills. So I recommend everyone here, like if you wanna solder anything for SMD for your PCB board, use 0805. Okay, so let's use 0805 for them both. So for the stepper motor here, we go here and just use this first one stepper motor. For 2 holes might be good as well. I don't know, like Zubin did this like because he could not find out like the orientation of that stepper motor. Like there was a plastic bit of it. I would suggest cutting it directly after getting the stepper motor, because like that plastic bit like means nothing and it's so like annoying there. So for the resistors, go to resistors. Where are resistors? Resistors. We cannot find any. Why? Okay, here, resistor. So 0805 hand solder. Just go, go, go. Okay. So now, here's something a bit tricky, which is the potentiometer. We would like to use the potentiometer with 3 pins. Okay, that's the device we've got here. Like, let me show you that. Okay. So this is the potentiometer that I'm using for my circuit board. And you can see like it has 3 pins. The side pins, like if you are connecting them to the multimeter, it will read 5,000 ohms. But like the middle pin there is meant for adjusting. So if you turn it to the very left of it, one point will be 0 and the other side will be 5,000 and vice versa. So the way you are using it should be connecting the middle pin to other pin on the side. Okay, so that's the way of using it. And if you don't know like how long are the gaps between those pins on the potentiometer, the easiest way of checking this is by pushing it to the breadboard. So as you can see here, I don't know if you can see this clearly. So, okay. So there is there's a pin in between 2 potentiometer pins, right? So it takes up 2 breadboard pins for the gap of the potentiometer. And as we know, like the gap of the breadboard pins are 2.5 millimeters, which means the gap between the potentiometer pins are 2 times 2.5, which means 5 millimeters. So that's the kind of footprint that we want to use for it. So let's try finding it. Potentiometer. So this thing is definitely not surface mount soldering. It is through hole. So THT. And here we go. We've got so many of them right now. I'm not sure which one should we use. Because it's see like it is all over here. But let me see. if you are encountering something like this, I'd recommend Google it first, of course. Let me check. If I say like potentiometer, KiCAD 3-pin footprint. No. Does it give me anything like related to pin selection? No, like right, there are a bunch of symbols or like footprints, but I cannot say which one should be the. Oh, okay, see, KiCAD footprint for 5mm 3-pin potentiometer closed. Okay, it is closed, so someone must have given an answer for it. Is there anything useful? Well, I cannot see any like specific footprint name here, which means like it's pretty awful. Okay. To be honest, I forgot how did I figure this out when I was drawing, like plotting with my previous oh damn. See, I've lost my I've lost my selection. Okay. You definitely need to learn like how to keep saving your additions like throughout your PCB designing. Okay. I need to do these things all over again. LED, SMD. What? It is not there. Hand solder, and demo motor, resistor SMD, OA05, hand solder. Okay, and I would like to click OK this time to save it. And let me check that out pretty quickly with my previous design. Okay, that's pretty fortunate for me. I found it. So what I was using was this potentiometer through hole Piher, right, Piher thing here. But I need to check like which one was the exact one I was using. I don't like this, to be honest. Like searching for the solution one by one. Piher horizontal, not this one. Single. Okay, this feels more like it. Let me check. Horizontal, vertical. It's definitely not vertical, it's horizontal. So dual or single? It's definitely single, right? There's only one row of my potentiometer there, and if we measure it, we'll see, yeah, 5mm. Okay, perfect. 5mm, perfect. So that's the footprint we want. Okay. Check again. Single horizontal. Okay. And now for switch 1, this is the SPDT switch we've got. And we can use the same technique as I mentioned before. Like if you can see, I don't know how to adjust the focus of my iPhone camera here, but obviously it like each gap of this switch here is exactly matching the gaps between the breadboard. So which means like those gaps are 2.5 millimeters. So if we want to find switch here, and to be honest, it's called like both buttons and switches are called switch for symbols, but like both of them are being called button switch here for footprints. This is pretty weird, I would say, but like that's the naming system of KiCAD. So we go here and we search SPDT, which will filter out most of those irrelevant footprints for us. And then we need to check these one by one. Not this one. No, the first one. Okay. So as we can see here, this is about 2 millimeters. 2 millimeters. You know, it might be too small for that. I think we can check here, like with my previous run, and see here. Here is my here's my switch, right? And it's definitely not that one. So we need to check even harder. Push, no. Slide, no. Hmm. Keyboard, no. SMD, it's not SMD, it's definitely through holes. Which one did I choose? Okay, I think I start to remember it. So, for some time, it is unnecessary for you to use a button or switches footprint for switches. Sometimes connectors here might still work. So if we select connector JST here, you can see like there are a bunch of connectors here, but what we want is those with gaps of 2.5 millimeters. Um, and as we know, like we had a row of pins and there are 3 pins in total. So what we would like probably is this y multiply 3 pins. So see, here we go. If we measure it, 2.5, 5. This is perfect. I like this. Okay, let's use this one. Okay, and next for the button, as we can see here, so this is a pretty typical button that we can use. You can find this in the makerspace. So it has 4 pins in total, but actually there are only 2 pins, like electronically speaking, because like those 2 pins vertically here as the column, they are internally connected. If you are using a multimeter, let me find one here. If you use a multimeter to test its connectivity, you will find out that, let me see if I can put this in a good spot, or maybe not. I put it here. Is it showing up? Maybe not. Okay, it is showing up right now, right? Okay, so if we can use a multimeter, switch it to the connectivity mode, and try to test. Oh, I don't like it. Let me try harder. Okay, here we go. The button. Oh, I need to find an assistant for me. Like, I need to find an assistant for me. Let me try if I can do this. Okay, this is better. A bit better. So if we try this, see, this is a beep, and these. Mm, uh, this is so hard. See, they're being connected. All right. So as they are internally connected, we don't need to add those things further, right? So which is good for us. And what we want to use is definitely button switch through hole here. And as we can see, like they are 4 pins on the button. So let's see this one. No. What we want is like it's likely this one SPST, but doubled by 2. So there are slide and piano ones. I'm not sure what's the difference between them. But what we want is definitely a squared one, right? Like not a how to say, not a rectangle one. Is there more of it? Okay. This is not ideal. Like every time I need to search them pretty carefully. This is not what I want, of course. Is it squared or rectangular? Oh, it's rectangular. Okay. I was wrong. Okay. Mm, button switch, and I need to use the same strategy to measure the width of the gaps of the stepper motor. No, not the stepper motor, the switch. Okay. So, okay. So I'm gonna measure it again by simply putting it on the breadboard. So as we can see, I don't know if you can see it, the gaps of those pins are 1, 2, 3, 4, 5 times the breadboard pin for the vertical side, and for the horizontal side, there are 1, 2, okay, just 2. So it should be 1.25 millimeters multiplied by 12.5 millimeters multiplied by 5 millimeters, right? Okay. So for this one, no, this is too small. We need a larger one. How should I find a larger one? Let me check. So, okay. Right, so I just realized that the one I was using was not these dip switches rather than this push, because this is a push button, right? And if we measure this like this, you can see like it's about 5, but not really 5. But you know, like those pins are just full, so it might still work in that case. And for this one, it's right. It's 12.5, which is exactly as we measured. Oh, this was 5, right? It's correct. Like, don't look at that. Don't look at those metrics on the ruler. Rather than you need to look at that value showing up as y there, right? Like that's the real result, not that ruler there. Like it is hiding. There's a 5 hiding here. Okay, so this one is correct. Let's get it done. And the last one is the demo shell. See, like because since I've closed and opened this project for several times, this thing is not showing up here anymore. It is being alphabetically loaded and sorted. So I would think, or is it? It might be not there. Okay. Okay, so what I'm gonna do is to go back to the home page and manage the library. Um, Demos are here. Why not showing up? Oh, I know why. I know why, because there could be something happening. No? This is weird. Um, why it is not showing up on the left side of it? There's no demo shell, right? There's not. I don't like this. Open libraries. There they are. So why? Okay, I would like to restart it and see if it is there. This is definitely haunting me. Okay, this is still not there, but as we can see, they are here, but whatever. I'm just gonna reload them. Okay. 小 board, motor, and motor one is here. The SSD one should be here. Let's hope this time it will work. Still don't? This demo motor is not in the footprint library table. Okay, I might need to pause it and fix it up. Okay, I just restarted KiCAD and it is being loaded properly. Don't know why, but like restarting always solves the problem. Okay, double click, shell sense. Here we are, and press Ctrl and S to save it. Then let's go to the PCB view of it. Let's import it. Update PCB. Okay, you can see like there's no errors, no warnings, which is perfect. I like it. Okay. And now we can design our PCB and finally finish up the routing here. My suggestion first would be creating the edge cut. Okay, creating the edge cut first. I mean, like, it is unnecessary to do so, but like, this would be helpful for you to like have a pretty have a good intuition about how big your board will be like. When having that edge cut being created, I would always change the grid back to 0.1 inch because like if in that case I can make a perfect square without any difficulty. See, right, this is a perfect square, right? And now what we can do is to have the layout here being arranged. So what I wanted to do is to have the so first of all I would suggest maybe move this microcontroller to the near to this upper side of the PCB board because you want to be able to use this USB-C port here to upload your code on your microcontroller. So you definitely don't want to have it like in the middle of the PCB board. Like that would be really, really frustrating if you found out like you cannot upload your code to printing out your board, right? And the next thing for this board is like we can see that there are through-hole pins here, like the microcontroller, the stepper motor, these orange pins here, like they are through-hole pins. But these red pins here, like for the resistors and LEDs, they are surface mount pins, which means actually these pins should be going, these devices should be on the other side of the resistors and LEDs to make sure that their soldering pad are on the same side. Because this is for PCB board, the side, like each side of them is not connected, right? There's no current or like a circuit going from the one set to the other. You can only, or like at least for our labs printing, you can only print those wires or layouts on one side of the board. But like like some good manufacturing companies, like they can print both sides. So if you are gonna use the manufacturer's fabrication, you can definitely have like both sides printing layouts there. But if you want to test it out in our lab, you can only do it in one side. And to make sure those through-hole pins and SMD surface mount pins can be connected on one side of the PCB board, the first thing you're gonna do is to flip all the through-hole pin devices to the other side of the board. So the way of doing this is pretty simple, is to select this thing first, this item first, then press F for flip. So F for flip, F for flip, F for flip, F for flip. You can see like all these digits and characters are being flipped as well. So you can make sure like they are on the other side of the board. And you can also check this by looking these courtyard edges. Like if they are bluish, this means like they are on the other side of the board, and they are reddish, like they are on this side of the board. Okay. So I would like to create this one to be here, and maybe the OLED screen to be here, I would say, because right, I think this is good, and this is the power switch. I'm not sure where to put it, but first thing, I would want the user to be able to adjust this potentiometer pretty easily on this side. And I want this thing that the user can squeeze and turn to be extruding from the PCB board, because otherwise you cannot have your hand inside the board to manipulate it, right? So I want this part of it to be left out. And for the button here, I would suggest rotating it somehow and have it here like with the potentiometer, so you can easily have it. And for the switch, maybe on this side of it, and the rest of the thing would be like how to connect those resistors and LEDs. Okay. So now, based on these thin blue lines, what we need to do is to create tracks to connect those pads together. And before that, what we can do is, of course, to rotate this, to rotate and move these pads and devices a little bit to make sure like they can be like easily connected, right? Just some routing tricks or what. This is meant for, I think this is meant for power, right? D2 is for power or button, or it's for button. If it's for button, I will leave it here. Let me check, is D2 for button or... Yeah, it's for the button, it's not for the power. So I will make it near the button, and this LED could be here, and I would like the switch to be not so sure. Why all ends of it are being used? This is weird. Okay, this is weird. So I found something wrong with it, which is like this one is the LED is lighting up when the MCU is not being powered. So this is definitely not what we want. So I'm gonna use backspace to edit this line and create it like this to make sure like when the MCU is being powered, the LED will go up. And afterwards, you can just go back to the PCB view, press this again and update it. And now you shall see that, right, the configurations here, you can see like those thin blue lines are being connected to 2 pins only for this switch. And yes, this thing, yeah, I think this is a better way. And R2 is for, R2 should be with potentiometer. So I will make them as close as possible. And since the other side goes to the ground, there's no need to be concerned about these 3 thin lines here. Like connecting either of them should be fine. And D1 shall be with the button. So I would say I would tweak the button a little bit and make sure it's being connected like this, so I can have the D1 here and R1. Okay, it can go there. Like, okay, it's fine. Okay. One way I don't like this is because like there's a pretty big free space here, like, and it is being wasted, like nothing is there. But it's okay. Like, you can use a ruler here. Is there a ruler here? Yeah, to measure like how long is it. It's about 66 millimeter wide and less than 80 millimeter long. So it's not a really long device. Okay, it's not so big. I think it's okay. So right now we can start to create these tracks, but there's one thing I need to do as well, which is to set the tracks width and preferences. So what I did was to click here. You see, like here's a track, use net class width, and I'm gonna edit it. Go to net classes, and you can see that by default, the configuration is showing up there. Let me check if this is the desired default for my setup. Okay, not really. I would like to set it as like this. You can just follow my command here. You can just follow my setup here, and yeah, don't need to tweak about the others. And another thing is that for standardized manufacturing, the tracks representing the powers, including VCC and ground, should be at least 0.5 millimeters wide. So what I'm gonna do is to add another net class named power and have its track width as 0.5 millimeters. Then I'm gonna set up rules about which lines should be plotted or drawn or should be plotted or drawn with power net class. So I'm gonna say like G and D shall be power net class. VCC shall be power net class as well. Okay. Alright, and now we can start plotting. Let's start from the switch. Okay, as we can see, like there's a VCC pin here, and it should go to, oh, that far. Why that far? I don't get it. Like it can do anywhere, right? Like that switch can literally goes to anywhere, I would say. Uh, okay. Why not just have it connected? It's refusing to do so. Why? I don't know. SWIC. Okay. I see why. So the reason is because this VCC represents the pins or lines or wires before being controlled by this flag, by this switch here. So if we are connecting VCC straight up from here to here, this means the same thing, and this OLED screen's power is not being controlled by the switch here. This is definitely not ideal, and what we can do is a little bit tricky but viable, which is to use 3v3 as the power source for VCC here. But I'm not gonna draw it like that. Instead, I'm gonna have it like this. Okay, ugly, but workable. So if that's the case, VCC is only providing the power for the MCU for 5-pin input voltage, and 3v3 is the output for the for all the other devices. I think this one is better. So let's go back to here and update PCB, and we shall see that if we want to connect this thing, oh, it goes to nowhere. Why? It goes to nowhere. This is also not correct. Okay. So the thing is, there's no power supply for this MCU yet because it is not being plotted or being drawn from the schematic, which is fine because like if you're only using the 5-volt pin voltage input, you can just solder a power box with wires to that pin directly, right, without any difficulties. So I might just leave that part off. And what you can do is to have one side of it yeah, what you can do is definitely have one end of this to the switch and the other end can just go to the power battery, and running them together. I think that's fine, right? I think that's fine. Right, I get it. Now I get it. Okay. So I think we can leave that a little bit further because we can have other parts to be connected together. For example, we can connect the stepper motor first. See, like since this is not this is not a wire for power, it is using a thinner width for plotting, and it should go to that to that part of the microcontroller, which I don't like. I would like to see if we can rotate this to make it better. Yo, here it is. Let's see. I would like to give it more room for the pins to be connected as follows. So see, we should connect this one from this side, or otherwise this pin cannot be connected from this side. I mean both are okay, but like there are better ways, right? And switch should go all the way up from here to the 5-volt pin, but ground is, oh, this is too tricky. Let me think. This is not good. This is not a good wiring. Because the ground pin here is being blocked. Let me see if I can save it by. Okay, it's savable. And as you can see, like, because since this is the grounding pin, the width of it is being automatically adjusted higher. So I'm gonna just do this and this, this. I think this is not ideal. Might wanna rotate it. And this is for the potentiometer. And why pin 2 is not being used? This is also weird. Okay, so here's the thing. We should be connecting this one to pin 2, right? Not pin 1. Okay. Let me see. But why pin 1 is connected? This is also weird. VCC. No. Right. We are gonna use pin 2. Yeah. Yeah. Now it's correct. Now it's correct. Right. Right. Pin 2. Because pin 1 and pin 3 like it's not adjustable. Yeah, I definitely made some mistakes. Okay. And let's do the routing. Here it is. Oh, so this is the ground, I see. Oh, it's being blocked. Let me see if there's another way around of routing. I think there is. Let's see. Right. I like it. I don't like it. Because we need to definitely want to avoid those square angles. So that's why I'm drawing it like this. And yes, for this one, I would rather try connecting it to here, but not upper. Okay. Oh, and the buttons shall be connected in this way. Oh, this is weird. I don't know if this is automatically connectable, but right, it's not. It's not. So, since it's not able to connect in this way, I would say that something is definitely is routing wrong, or the position of these things are wrong, right? So what I want to do is we can still have these easy ones to be connected first. But those difficult ones, how am I gonna do with it? Right. So as we can see, the button is too far away from this MCU, so like it is not connectable through here, and maybe I need to, well, I need to have it rotated back perhaps, to make sure like it is like there's enough room for it to like for that kind of wire to go through. Okay, so that might be it. So right, I might gonna follow up and solve these problems later. And as you all know, like this is not an ideal PCB board printing uh, from as for now. So I will add several parts of it later in the following up videos, including rechargeable battery connections or like correct AAA power box connections. And I'm also gonna uh, do something like a better wiring of these PCB boards and something like that. Yeah. I will finish up these boards in the next tutorial and I will make it being uploaded by the end of the year tomorrow. Alright. Thank you for the watching and hope to see you in the next class.